So we're going documents advanced. Advanced, we're talking about whiteboard. How do I share the whiteboard? What's happening? How do I share the whiteboard?
Just press whiteboard and then press new whiteboard.
They have changed it. Earlier, I believe there was no separate menu. Maybe I forgot. Okay, so
So
I
I
just
loaded the whiteboard.
okay. I have just opened the new whiteboard. See, I
Alright.
guess Zoom newer version they have got some sort of modification. Do you see the whiteboard?
Yes, sir. We can even edit on the whiteboard.
It's getting loaded at my end. So give me a sec. All right. So yeah, so they have got it made it much more advanced than it was earlier. Oops, what happened? Oh my God. So they need to sign in. If you don't sign in, this guy is going to take ages. And no, sorry, it's not coming again. So now, given that you asked this question, Arav, I think it's important that we understand the computer a bit more. Okay, I think it's going to be useful to all of you. Some you guys may already be knowing, and some I'll probably, if you already know, is fine. If not, then it can help. Okay, just to understand things underneath. Okay. So you see, you guys already know that you have some sort of your CPU, right? You know that all of
Right, sir.
yeah. And then of course it was told to you that you also have some sort of input, right?
Yeah.
Right? And output. That's kind of the fundamental thing that you have been told.
Right, sir.
So we'll try to dig deeper, a little bit deeper into these three, and this should actually help a bit. So essentially, what is an input, right? Uh, what's an input is basically if you see the CPU as some sort of a black box, right, which has a unit associated to it that we call it, let's call it input controller or input driver. So this is an input controller, which I guess, can I have some sort of linkage here? Right. So this input controller is whatever, let's say you're putting stuff on your keyboard, right? Whatever key are you hitting, that is being that is actually reaching this input controller, right? So this, assume there's some sort of magic out there. Similarly, you have something called output there may be some real different terms. I really don't know those terms. I may have forgotten. But for the simplicity, assume there is something called output controller. The role of this output controller is to push data on the output. Okay. So far, so good. Yes or no?
It's good,
Yes,
sir. Yes, sir.
Then you have something called microprocessor.
Mm-hmm.
Spelling microprocessor. And you also have something called, let's say, disk, your or storage. Let's call it not the, let's stop calling this disk anymore. Let's call it the disks. Now it's not disk actually. So calling it disk is bad. So some sort of, let's call it
hard drive.
permanent storage. Let's call it permanent storage.
Sure, sir.
So the way things happen, and there's another thing called, which is here called uh, random. Okay. So on this permanent storage, okay, on this permanent storage, there are sections. So how do I change the sections? Maybe this. Can this be changed? Why I'm not able to get a circle?
So you
You
can
know
just use pen.
I have to use pen.
Oh, yeah.
Wait,
Wait, you mean a shape like this, sir?
I think that's
yeah, circle.
perfect. Thank you.
And so you can also make a mind map. There's like this mind map function.
Sorry.
There's also this mind map function. Like if you want to like,
Mind map.
yeah, there's a
Oh,
function over here.
interesting. Okay.
Yeah,
I'll explore it later on.
Yeah, it'll be useful for like stuff like this.
No, very nice. Thank you. All right. So let's say, so this is permanent storage. So what really happens is there's some way, there's some way we call it, let's call it simply directory service. Okay. So there's a directory service that is capable of giving you, kind of, I would say, right. So there is directory service. Sorry. Right. So there's directory service that is that can actually give you access to or read the files. So there are files stored on this. Let's say file 1, file 2. Of course, there are numerous files. I'm just kind of making it simple. File 2, file 3, etc. Right? So this directory service is there, which is capable of reading those files, right, and giving them to you. So this is like when we when in our code, you remember we created a C file.
Right, sir.
Yes, sir. Yep.
So I'll probably share my screen back again. Okay, but I think let's talk through memory only. So we created a file called
In something.
student.c. We created a file like
No,
that.
student attendance.c, I think, but whatever.
I think it was student.c. So we created a file called student.c. So then let me just remove this further to kind of make things clearer. Okay. And if you remember, we executed a command. Oh, sorry, where is it? We executed a command gcc student.c. Remember? Anybody?
Yes,
Yes,
sir, I
sir.
remember. Sir, what does GCC do?
I'll share. I'll share. That is important. How come I'm not able to go to the right side of things?
Just scroll like that.
Yeah.
How do I scroll?
Oh, just use 2 fingers and scroll.
On the trackpad, and then
Yeah,
gradually
trackpad.
drag your fingers to the
Yeah,
left.
use 2 fingers.
No, like swipe with 2 fingers to the left.
Yeah, swipe with 2 fingers on the trackpad.
Right. So we called this command gcc student.c, correct?
Yep.
Correct.
But after that, we executed another command after this was done. We said ls minus l. That's what we did. Correct?
Correct, sir.
I'll probably go back. I'll share my screen back again, but let's see. Let's go. And then what we did, we simply said dot slash a dot out. We did these three things. Correct? Remember any?
Right, sir.
So with you guys in front of me, I created this file myself, student.c, and that we before we when we were writing that data in the student.c, before that we actually executed another command called vi. Anybody remembers we did that, right?
Yes, sir.
Correct?
Yep, I remember, sir.
Look at it. There are vi, gcc, ls. There are three things, and like and after that dot a dot out, which is kind of a bit unusual to you. So now let me try to explain. So this vi, like you have file called student.c.
Right, sir.
Similarly, there's a file called. Similarly, on this file system or the storage, if I kind of increase this size, in this file storage, we have a file called vi. Similarly, on this file storage, we have a file called ls. Okay. And similarly, okay, let's talk about these three first. Student.c be created in front of you. vi,
Right.
so vi is actually a file. Okay. Now, what really, but the difference is the vi is an executable file. Now, let's talk about what is an executable file. Okay. Are you guys okay so far?
Yes,
Yes, sir.
sir.
Yes, sir.
So vi is an executable file, and how does things work? Okay. So this now the role of this microprocessor comes to picture. Now let's look at this microprocessor and this vi. Okay. Now this
Yeah.
microprocessor is an interest is a let's not let me. And it's going to be go. Are you guys okay if I go a little bit into a little bit complex dimension?
No problem, sir.
Yes.
Yes, sir.
So now if I talk about, I hope I can share my screen and resume sharing my microprocessor. Let me try to do that. Screens.
I don't think it does that if you don't have account.
Let's see. All right. If not, it's fine. At least though we have those things in our memory. Is that fine? We can manage. Is that okay, guys?
Yes, sir.
Yes, sir.
All right. So typically like 8086. So in reality, what your microprocessor only understands, whatever depending on the microprocessor you have, they are like these commands. Okay, they're looking like this in your on your screen, like in plain English, but in reality, they're like some sort of combination of zeros and ones, which microprocessor understands, right? So the move command, which what it really means is moving so like so ultimately whatever what irrespective of whatever you the data processing is simply about copying the data from one place to other place, uh, adding or in reality the I mean we understand all mathematics, right? It's
Right, sir.
plus minus and then multiplication division, right? But
Right, sir.
finally, all those plus, minus, multiply, and divide, they are implemented using the plus only. That's how the microprocessor works. Okay. So in the microprocessor, if I kind of show you back again, let's say if a microprocessor has to do the add, like or maybe subtract 5 from 30. Oops, where is it? Okay. 5 from 30. Okay. Are you with me? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir.
So what will a micro, let's look at the sequence of things, what will happen. Okay. Now let me once again have another page. Let's say you write a code. Let's say int a is equal to int a, let's assume int a is equal to 30. Int p is equal to 5. And you have int c is equal to a minus b. Right? That's what the code is. Assume.
Yeah.
So what's going to happen? So if this is your microprocessor, so the microprocessor has something called registers. So it has the registers here, input register, multiple like two, like typically the 2 input registers, and you have an instruction registers. Okay. So you have input A, you can call it like they have some sort of, if I kind of share again, maybe 8086 microprocessor register name. There's some registers, you can say kind of internal storage of the microprocessor, right? Some data registers.
Right.
All right. So far, so good.
Yes,
Yeah.
sir.
What this guy is going to do is, let's say you got a, so initially, well, let's say you, this is what you're doing. So internally, what will happen is some sort of code like this will happen. Move, okay, move or copy, maybe something like that. I don't remember the instruction name. Maybe copy. Let's say A has location, whatever location it is. Let's say the A has the location maybe L001. Assume the location of in memory of A is L001. So this guy will simply say the code L001 to DX1. Right? The second instruction will be copy L00, sorry, assuming it is the B is at 002 to DX2. Correct? Then the third instruction will be move, something like that, move DX1 to your processor, something like that. Correct? And then add DX2, which means if this is DX1, this is DX2, and this is your, let's assume ALU. Maybe this is ALU itself, right? Right? Now it says A is equal to minus P. So it cannot say DX2 because you need to now, before you need to do that, you need to convert B to minus P. So you need to say something in word DX2. That's the kind of code, which means like make it negative, something like that, right? Or maybe complement or something like that. Okay. And then
Sir, I'm confused what the like DX1s like are. DX1, DX2, ALU.
okay, so these are like maybe it's getting more complex, even I don't remember as such. But the whole idea is what I'm trying to say is what you see here. Okay. So when you executed the command, as I said, when you executed the command gcc students.c, or maybe this file, whatever this code is, right? So this actually this converted, this created a new file. This created a new file named a.out. And this a.out file has these kind of instructions. I'm not saying exactly this, but these instructions, which is kind of your code, which can be understood by your microprocessor. Okay. And microprocessor is doing all the microprocessor does is, based on these instructions, whatever these instructions is, this guy is going to copy, like for example, with this instruction, this guy is going to keep the whatever it was there in this memory space 30, it will copy it here. With the second instruction, it will copy, assume this to here. Then this guy will do what? Because you wanted a minus b, so there would be some instruction which makes it convert to minus negative. So this guy will make it -5. Then with next instruction, this guy is going to add this. This guy is going to move this 30 here. Sorry. We don't have to know all this. I'm just kind of trying to make you understand how things work underneath, right? And then
Right, sir.
this instruction, this guy is going to add -5, and there is some sort of result. There is some sort of result register. I don't remember the name. So this guy is going to create that 25 here. And now there will be another instruction that is somewhat like store, maybe store res to maybe this less memory of C, that is L003. You see my point? And then as a result, your memory or where your C variable C will be having 25. So why I said all this is what ultimately this is what processor does. Processor is capable of reading the instructions in a binary form. Based on that, this all this guy is doing is manipulations in memory. So far, so good.
Yes, sir.
Akshar,
Yes, sir.
right? So this is all. So now when we were doing that other thing wherein like we were having that instruction, right? Let's say once again, rm a dot out. Once again, rm. So if you see like everything is a command, let's say if I say which ls, you'll see there ls file, the file named ls is lying here, right? I don't like head. I know it's going to be hard, but let me see. So you see there's some instruction like that, which you can't read.
Mhm.
And if you look at these things with the help of some sort of disassembler, you'll be able to see those instructions that we were looking at using the microprocessor instructions. Where it was, I don't know how to see that. Right. Like we had those instructions. Internally, all these instructions will be there. Of course, I'm not saying exactly this because we are maybe on a different architecture, but typically that's how it's going to be. And most of you don't need to get into this level ever, but this is there for your understanding. Is it getting complex, or are you guys able to absorb it so far?
You're able to observe it, sir.
Yeah.
Yes, sir.
So going back here. So what really happened was when we wrote, let me just do it again. ls minus l. So we created one file, student.c. Okay. So what really is happening is somewhere on the disk, Arav and everybody, we actually created this file. We claimed some space on the storage, your permanent storage. And in that storage, we started consuming 1481 bytes. So far, so good?
Yes, sir.
Yes, sir.
Yes, sir.
Is a text file. If you see students.c, the text file, we can read in the human, it's a human readable form. Now what we did is, if you see which GCC, let's take a look at which GCC. So ls minus l user bin. See, this is an executable file. Do you see that? Read, write, execute, read, execute, read, execute. Okay. What it means is this file has instructions that can be, or the the data that can be read by microprocessor itself directly. Right? How it reads it, that's a complex game. Let's not get into it. But at a macro level, understand that the microprocessor is very simple thing. It's a dumb thing. It will see everything that you have like part of this instruction. For example, let me just try if I can ask for help from Gemini. Can you show me the assembly code for against a C program where simply adding the content of room and storing it in a so I guess this guy's perfect. It is simple like the way we did, right? Do you see this?
Right.
If you see the assembly code corresponding to this guy simply said, first is the data section. So in assembly code is saying, I have an instruction called DD, which means declare. Okay. And this guy simply saying data section, which is in variable A, wherever the path is, I need to store 10. I need to store 20. Declare a variable B is initial value 20 and is sum where is the initial value of 0. Correct? Then it says my code section, which is my function name is main. Do you see this?
Yep.
And the instruction is it's saying move EAX, which means I need to move what is there in the memories, in the A, the location A, like that's how it's writing location A to EX. Now you can see this in English, but essentially whatever in the file that you see, everything will be in the binary form. Okay, this is a level. One level below the before the actual binary code that actually processor reads. Okay, then it simply says add EAX, which means whatever is there in this register that you have, you got 10 here, right? Earlier, you got 10 in this. You got in EAX register everything that was written in A, right? So which means EAX will be having 10 now, correct?
Correct.
Akshat, Krishna, are you guys able to follow?
Yes, sir.
Yeah.
Sir, I had guests at home. Will it be all right if I leave?
Yes, you can. I'm recording, so you can actually take a look later. Not a problem.
Yes, I'll definitely take a look at the recording, sir.
All right, go ahead. So
Thank you, sir.
So
Bye.
then, if you see the next one, it says, instead of moving the data to another register, this guy is simply saying, whatever is in EAX, add to that what is there in the location B. Krishna, Arav, are you able to see that?
Yes, sir.
Yeah.
Now this guy is simply saying, whatever is there in the EAX register, right? Move that or copy that to this location. Correct?
Correct, sir.
So ultimately everything gets translated into this. So what you see on the screen happens like that. So this GCC is a special, GCC is like the way you have written your program. So somebody has written, of course, like some more complex program, GCC, which is capable of reading your file, right?
Right.
And after reading, this guy is capable of converting this code into the file, an executable file that processor understands. That is A.out. Correct? That's how,
Correct, sir.
like you can create a file, GCC can create a file. Okay. and then GCC created a file, and then this file is simply an executable file that you can run. Do you see that?
Yes, sir.
Hello? Krishna, I can't hear you.
Yeah, sir, I was on mute for a minute.
Okay. So the whole point is why, like, we reached this point. So I was kind of trying to show you the code earlier. So earlier what used to happen was people used to start, when they started, they were writing to the files, okay, their data, right? And then they were able to read from the files. And that was a complex job in the sense, yes, for a very, very simple thing you can do with the file, with the, you have for the persistence. But when it comes to problem, right, wherein today I'm a single person, right? But
Right, sir.
you want to have 5 people, okay? Then what will happen is, or everybody need to access the data, right? Then what will happen is somebody need to access. So then those kind of a complex storage requirements, people evolved the concept of databases. So the, what a database is essentially, fundamentally, even the database is like that. It's just that if you once again, if you show my screen. So fundamentally, if a what simply a database is, right? What database simply saying is, okay, now you stored in a comma separated file, and when you read it, of course, you need to parse it. Yes,
Right, sir.
that's how you can create different columns and fields. Now there can be
Correct, sir.
amount of data that you need to manage. Moreover, if the data itself, then you have to also manage the complexity that if the data becomes too high, where the storage will be happen. Can this, if do you need more disk? Do you need to split the files? How to speed up the reading the files, right? There's so much complexity.
Right, sir.
Krishna,
Yes, sir.
would the storage not be very complex?
Yes, sir.
Yes, sir.
Right. So then they said, you know what? We can relieve you of this complexity instead of you having to manage the files by yourself. Let me simply, you interact with me. That is, we call it database. Database, we can call it database services, right? And all you need to tell me as a database, you need to give me a structure, give me the structure that is called DDL, data definition language, like create table XYZ. Do you know, have you ever heard that?
Yes, sir. Well, no, sir.
Right? Then, okay, then you give me another set of, and I'll give me another set of instruction, give me data. Like play with the data, I can solve it. Now that is everything, which is your, which is called DML, data manipulation, which is insert, update, delete. Correct? Yes or no? Krishna, are you
Yes,
able
sir.
to? Now they said,
Yes, sir.
now because there has to be some sort of standardization, otherwise things are going to get very complex. They said, in order for you to manage all that data, I'm going to make your life simple. I'm going to offer you something called SQL, a language itself. That's called protocol, right? Protocol or the standards. So I gave you a SQL language that would allow you to define how do you want to store the data, and how and what do you want to store, and what do you want to do with the data, right? So that's the concept of database. But ultimately, this is, I mean, at a very, very fundamental level, database is nothing but a specialized program or set of programs which are working together to allow you to save and and retrieve data. So far, so good,
Yes, sir.
right? So now we had another set of challenge with the data, right? That we wanted this data to be accessible from anywhere. So that's when they said there will be another layer of security that they added from services, that is your authentication. which means this service will have your user accounts, who can access which data, right? So they had all these things. Now the database itself became a very big thing. So far, so good,
Yes, sir.
right? So, but fundamentally, even with the database, underneath is files. How different databases manage files is it's a different story. And in most cases, you don't need to be aware of how a database stores the data. But yes, you need to be aware of, in your context, how do you need to use these services or the database which are suitable for your requirements, right?
Yeah.
Let's say if you have to store maybe 10 gigabytes of data per day, then you'll think differently. But let's say your entire need is just about maybe 100,000 records throughout the lifetime of your application. Then it doesn't matter to,
Yeah.
like, I mean, most of the time it doesn't matter to get it into details, right? Moreover, it would also define what kind of which database you use based on your use case. So now it becomes a game of expertise. But at fundamental level, as I said once again, it's just about storage and persistence. Are you able to get me on that?
Yes, sir.
Right. Now there's another important dimension that moved beyond it. They said, okay, now the database is, I'm running this whole set of services. Maybe what they have, for database they have maybe a cluster of services. Okay,
Right, sir.
cluster means I am a database, right? I'm a
Right.
big database,
Mm-hmm.
and in this big database, instead of managing on one single machine, because I need to give you a lot of performance or whatever your requirements, I may be managing with 100 boxes, 100 machines, right?
Right, sir.
But you don't need to be bothered about the complexity. All you need is an IP address and a port. That's it.
Right, sir.
So and this is a similar concept of your web services, right? For example, you have your complex business logic, and that's when you do so you have your complex business logic, which is maybe which is involving 100 classes, right?
Right, sir.
What you say, okay, you don't have to bother about those 100 different classes, because your need is simple. You just tell me, I'm going to give you an API, which means IP, port, and of course your whatever resource name, etc., and of course get the interface, and I'll manage the complexity. You just give me that on you hit me on HTTP call, give me, provide me the inputs, and I'll take care of the stuff. Now this complex logic I can offer through web, but I can have the same logic offered with the way we were doing. I can always offer this using a command line on the same box,
Right, sir.
right?
So we have less than a minute left on this
On
meeting.
this.
That's fine. I think we are done anyway. So
Okay.
this is all what I wanted to share today. I hope it was useful.
Mhm.
Yeah. Thank you, sir.
It was useful, sir.
Right, so
Yeah,
please
definitely.
always be aware. Yes, when the size grows, things become complex, but fundamentally everything is simple. But you need to have a good understanding of how things are work underneath. All right.
Mm-hmm.
Yeah. Thank you, sir.
Right, sir.
Okay. Have a good day. See you. Bye bye.
Okay,
Bye-bye.
sir. Bye.